Hey, everyone. Ever wondered what kind of secrets are hidden behind the rusty fences and decaying concrete of abandoned government sites? What if the public story, like weather control, was just a convenient smokescreen for something else entirely? Imagine a vast, desolate stretch of land, somewhere remote enough that few people ever stumbled upon it, yet strategically located for reasons only understood by those who built it. Here stands the skeleton of something colossal, a silent testament to ambition, secrecy, and eventual abandonment. Known locally by hushed rumors or sensationalized headlines as America's weather control facility, its physical presence is undeniable. Towering structures, remnants of massive antenna arrays clawing at the sky, concrete foundations that once supported immense generators, and buildings large enough to house complex laboratories or command centers, now just empty shells echoing the wind. The air here feels different, charged not just by the dry climate but by the lingering questions. What was this place? The myth of controlling weather is compelling, a staple of conspiracy theories and science fiction, but government projects of this scale, especially those shrouded in secrecy, are rarely built for such a singular, publicly fantastical purpose. The reality is almost always more complex, more rooted in the practical strategic needs of the era. This facility, whatever its true function, consumed vast resources, employed countless engineers, scientists, and military personnel, and operated behind layers of classification before simply being shut down and left to the elements. A giant, silent question mark on the landscape. Its sheer size and the sophistication implied by the remaining infrastructure tell you this wasn't a small undertaking. It speaks of a time when national security concerns fueled ambitious, sometimes outlandish projects without much public oversight. The phrase weather control itself might have been intentionally leaked misinformation, a perfect distraction, conjuring images of ray guns and storm manipulation while the real work, perhaps more mundane but strategically vital, went on behind closed doors. The true purpose of a facility like this wouldn't be about causing hurricanes or stopping droughts for civilian benefit. If it involved the atmosphere at all, it would be for military advantage. Communication, surveillance, navigation, or perhaps something even more obscure. Our journey into this abandoned site, piecing together fragments of information from declassified documents, or what should be declassified documents, local accounts, and the physical evidence left behind, isn't about confirming a sci-fi fantasy. It's about stripping away the myth to find the real, gritty, and perhaps equally unsettling truth of what America was building in the shadows, and why it was ultimately left to decay. The sheer scale of the operation, the isolation of its location, the type of equipment hinted at by the ruins, none of it screams weather report, but rather something far more focused on projecting power or gathering intelligence on a scale previously unimaginable. What do you think was the most likely, real purpose for a massive secret facility rumored to control the weather during the Cold War? Let me know in the comments as we delve deeper into the mystery. The desolate location was no accident. Chosen for its remoteness, minimal radio interference, and perhaps specific geological or atmospheric conditions, the site was miles from any significant population center. Access roads were few and heavily guarded in its operational years. The facility itself sprawled across several square miles, dominated by the ghostly frameworks of antenna towers. These weren't typical communication antennas. Their scale and design suggested a purpose involving powerful electromagnetic transmissions or reception, possibly interacting with the ionosphere. Concrete pads marked where generators, likely massive and consuming prodigious amounts of power, once sat humming, feeding energy into the intricate network of cables leading to the arrays. The main building, a squat, brutalist structure, was fortified, its windows small and barred, its entrance designed for security, not welcoming guests. Inside, even decades after abandonment, the layout suggested a highly organized, compartmentalized operation. Control rooms, laboratories, offices, server rooms, or their equivalents for the era, and sprawling areas that might have housed transmission equipment. The air inside was cold, still, and carried the scent of decay, dust, and something metallic, perhaps residue from the experiments or the materials used in construction. Exploring the site felt like walking through a paused moment in history, a snapshot of a specific kind of technological arms race. The sheer effort involved in constructing this complex in such a harsh environment was staggering. Roads had to be built, power lines run across vast distances, tons of materials transported, and a dedicated workforce housed and maintained on site. This wasn't a temporary research station. It was a permanent installation designed for long-term, high-intensity operations. The level of investment screamed national priority. Yet, despite the scale and expense, details about the project remained scarce outside of official circles. The few locals who knew anything about it spoke of strange lights in the sky, unusual atmospheric phenomena coinciding with the facility's operation, and strict warnings to stay away. These anecdotal accounts, filtered through rumor and fear, likely contributed significantly to the weather control legend. After all, if you saw massive antennas pulsing energy into the sky and then observed unusual weather patterns, it wasn't a giant leap for an uninformed observer to connect the two, especially in a climate of Cold War paranoia where the enemy was presumed capable of anything. The facility's design elements themselves offered clues. The specific configuration of the antennas, likely phased arrays, suggested the ability to focus and steer electromagnetic energy with precision, not just broadcast omnidirectionally. This capability would be crucial for tasks requiring targeted interaction with the atmosphere or distant objects. The power requirements pointed towards operations involving high-energy transmissions, far beyond what would be needed for standard communications or radar. This was about doing something with the energy, not just sending information. Understanding the real purpose required looking past the intimidating facade and the public myth, delving into the strategic thinking and technological capabilities of the time. It meant considering what problems the US military or intelligence agencies were trying to solve in the mid to late 20th century that would necessitate such a facility. The genesis of the project, shrouded in classification, can be traced back to the height of the Cold War, a period defined by an intense technological arms race and deep-seated paranoia. Both the United States and the Soviet Union were pouring vast sums into research and development across all domains: nuclear weapons, missile technology, space exploration, and electronic warfare. It was in this climate of existential competition that ambitious, sometimes scientifically speculative projects received funding if they promised a potential strategic advantage. The weather control facility, or whatever its internal project name was, likely emerged from discussions at the highest levels of government and the military, possibly involving agencies focused on advanced research like DARPA, Defense Advanced Research Projects Agency, or specific branches of the Air Force or Navy concerned with long-range capabilities. The perceived need for such a facility would have been tied to specific intelligence gaps or operational requirements. Perhaps existing radar systems weren't sufficient for detecting targets over the horizon, or communication channels were vulnerable to jamming or limited by atmospheric conditions. Maybe there was a push to develop entirely new forms of surveillance or disruption technology. The initial proposals would have been highly technical, outlining the scientific principles, engineering challenges, and potential strategic benefits. These documents, if they still exist in unredacted form, would hold the key to the facility's true origins. Building a project of this magnitude required navigating complex bureaucracy, securing massive budgets, likely hidden within larger defense appropriations, and assembling a team of top scientists and engineers from various disciplines: physics, electrical engineering, atmospheric science, computer science. The security clearance process for such personnel would have been rigorous, emphasizing the sensitive nature of their work. Early site selection would have involved extensive surveys, considering factors like seismic stability, access to power and water, or the feasibility of generating it locally, and the atmospheric conditions relevant to the planned experiments. The chosen location, far from prying eyes and sources of electromagnetic interference, underscored the secretive and potentially disruptive nature of the research. Construction itself was a monumental undertaking. Heavy machinery, specialized materials, and a large construction workforce had to be brought in and supported in a remote environment. The project likely faced significant logistical hurdles, budget overruns, and technical setbacks, par for the course with cutting-edge, large-scale government initiatives. Engineers had to solve problems related to generating and handling immense amounts of electrical power, designing structures capable of supporting massive antenna arrays and withstanding extreme weather conditions, and integrating complex electronic systems. The involvement of multiple contractors and subcontractors, each responsible for a piece of the puzzle, added layers of complexity and potential security risks, necessitating tight oversight. While the public or even many lower-level workers might have been given a simplified, potentially misleading explanation for the facility's purpose, perhaps related to generic atmospheric research or radio astronomy, those at the core of the project knew its true strategic intent. This deliberate obfuscation was standard practice during the Cold War to protect sensitive research from espionage and maintain an element of surprise regarding technological capabilities. The very decision to build something so large and so secret in such a remote location speaks volumes about the perceived stakes involved and the potential strategic advantage it was expected to provide. It wasn't just an academic exercise. It was a tool in the global power struggle, a piece of a much larger puzzle aimed at gaining supremacy in the unseen battlefield of electromagnetic spectrum and atmospheric manipulation for military ends. The visible infrastructure, particularly the immense antenna arrays, was what initially fueled the weather control rumors. From a distance or even up close without technical understanding, these structures looked alien, powerful, and capable of influencing the sky. The main array likely consisted of dozens, perhaps hundreds, of high-power dipole antennas, arranged in a grid or some other configuration optimized for directing electromagnetic energy upwards into the ionosphere, the layer of the Earth's atmosphere containing a high concentration of ions and electrons, starting about 60 kilometers up. The ionosphere is crucial for long-distance radio communication because radio waves can bounce off it, allowing signals to travel over the horizon. However, the ionosphere is also dynamic and unpredictable, affected by solar activity and other natural phenomena. The cover story, if there was a semi-official one beyond total secrecy, might have involved studying the ionosphere or atmospheric effects, which is true in a narrow sense, but omitted the purpose of that study. A plausible technical basis for the weather control myth lies in the known effects of high-power radio waves on the ionosphere. When powerful radio signals, especially in the high-frequency HF range, are directed into the ionosphere, they can heat localized regions, changing the density and distribution of ions and electrons. This phenomenon, known as ionospheric heating, can create artificial plasma irregularities. Scientists have studied ionospheric heating for decades using facilities like HAARP, High Frequency Active Auroral Research Program, which, though controversial, primarily serves legitimate scientific research purposes, such as studying the aurora borealis, geophysics, and radio wave propagation. However, a secret Cold War facility with similar or even more powerful capabilities could have explored potential military applications. For instance, by creating artificial irregularities in the ionosphere, it might be possible to disrupt or enhance radio communications over specific areas, interfere with radar systems, or even potentially influence the paths of certain types of signals used for navigation or surveillance. While directly causing rainfall, hurricanes, or tornadoes is outside the realm of physics, as we understand it with such technology, influencing radio propagation could have significant strategic implications. Imagine being able to create a mirror or an absorbing layer in the ionosphere to block enemy radar or communication, or conversely, enhance your own signals over a specific target area. Such capabilities, if achievable, would be a major advantage in electronic warfare. The public, seeing massive antennas and hearing about ionospheric research, might leap to the most dramatic conclusion: controlling the weather itself. The sheer power consumption of the facility would also lend credence to its perceived capabilities. Generating and transmitting megawatts, potentially gigawatts during peak operations requires massive infrastructure. Power plants, perhaps diesel generators or even a dedicated power line from a distant grid, transformers, cooling systems, and extensive wiring. The hum of these machines, the heat they generated, and the visible power lines converging on the site would have been undeniable signs of a massive energy-intensive operation. This energy output, coupled with the directed antennas, fit the mental image of a machine capable of manipulating natural forces. Early rumors might have started with workers or military personnel who saw unusual phenomena or were given deliberately vague explanations, which then mutated and grew as they spread through the local community and beyond. The government's natural inclination towards secrecy only fueled speculation, allowing the most sensational theories, like weather control, to take root and flourish in the absence of verifiable information. The reality, though perhaps less dramatic than controlling storms, was likely focused on a different kind of control over the electromagnetic environment and its impact on strategic military operations, a purpose equally significant in the high-stakes game of the Cold War. Stepping beyond the plausible cover story of atmospheric research, the real purpose of the facility likely centered on gaining a significant strategic advantage in the crucial realm of long-range surveillance or communication during the Cold War. One of the most pressing military needs of that era was the ability to detect and track objects, particularly ballistic missiles and bombers, over vast distances, often beyond the line of sight. Traditional radar systems are limited by the curvature of the Earth. This is where over-the-horizon, OTH, radar technology comes into play. OTH radar works by bouncing radio waves off the ionosphere to detect targets thousands of miles away. However, the effectiveness of OTH radar is highly dependent on the state of the ionosphere. If the ionosphere is disturbed, unpredictable, or deliberately modified, OTH performance can be severely degraded or enhanced. This facility's massive antennas and high-power capabilities align perfectly with the requirements for a sophisticated OTH radar system, or more likely, a system designed to understand and manipulate the ionosphere specifically to optimize OTH radar performance, or perhaps even to develop countermeasures against potential Soviet OTH systems. Imagine a project aimed at creating a controllable ionospheric mirror. By precisely heating and modifying specific regions of the ionosphere, the facility could have attempted to create ideal conditions for bouncing radar signals further, improving detection ranges, or conversely, creating holes or noisy regions to blind enemy systems. The scale of the antennas and the required power point towards an experimental system pushing the boundaries of what was thought possible at the time. This wasn't just passive observation. It was active interaction with the upper atmosphere on an unprecedented scale. Documents from the period, if pieced together from various archives, might reveal project code names related to ionospheric sounding, propagation experiments, or active atmospheric modification that, while technically accurate, obscured the ultimate military objective. Personnel accounts, if any could be found and verified decades later, might speak of frustrating attempts to achieve stable, predictable effects on the ionosphere, of chasing elusive phenomena, and of the constant battle against natural variations in the Earth's atmosphere and solar activity. The technical challenges would have been immense. Precisely directing massive amounts of energy into a dynamic and turbulent layer of the atmosphere, predicting and measuring the resulting changes and correlating those changes with strategic objectives required pioneering work in fields like plasma physics, computational modeling, primitive by today's standards but cutting edge then, and sophisticated control systems. The computers and electronics housed in the main building would have been state-of-the-art for the time, likely filling entire rooms with vacuum tubes or early transistors, dedicated to controlling the transmissions, analyzing returned signals, if it was also a receiver, and processing vast amounts of data about the ionosphere. The project wasn't just about building the hardware. It was equally about the fundamental scientific research required to understand how to effectively interact with the ionosphere for strategic gain. This facility was likely a massive, real-world laboratory, attempting to turn theoretical concepts about atmospheric physics and radio wave propagation into a reliable military tool. It was a high-stakes gamble, reflecting the urgency of the Cold War and the willingness to invest heavily in potentially transformative technologies, even those on the fringes of scientific understanding. The secrecy wasn't just about hiding capability from the enemy. It was also likely about managing expectations for a project that might not ultimately succeed in achieving its ambitious goals, a risk inherent in pushing technological boundaries so aggressively. Delving deeper into the potential strategic applications, the facility's purpose might have extended beyond simply enhancing OTH radar. Another critical area during the Cold War was communication, particularly with submarines operating in the vast, deep oceans. Standard radio waves cannot penetrate seawater effectively, making reliable communication with submerged submarines a persistent challenge. Extremely low frequency, ELF, or very low frequency, VLF radio waves can penetrate seawater to some depth, but transmitting these signals effectively requires enormous antennas, often miles long, and massive power outputs. While this facility's antenna array structure doesn't perfectly match the classic ELF/VLF designs, which often involve long grounded wires, the underlying principle of high power, long wavelength transmission interacting with the Earth ionosphere waveguide could be related. Perhaps the facility explored alternative methods for long-range communication or subsurface communication using high-power HF or other frequencies and leveraging controlled ionospheric effects. Imagine using the modified ionosphere as a sort of relay or lens to bounce signals into difficult-to-reach areas or improve signal reliability for critical command and control functions during a conflict. Another possibility, potentially more speculative but still grounded in the era's research, involves investigating the use of high-power electromagnetic pulses, EMPs, or directed energy effects. While a full-fledged EMP weapon would require different technology, research into the effects of powerful directed radio energy on electronics or atmospheric plasma could have been a secondary or exploratory goal. Could focusing immense energy onto specific atmospheric regions have unintended or deliberately induced effects that could interfere with satellite signals, disrupt communications, or even have psychological effects? These ideas, while sounding closer to science fiction, were often explored in preliminary research during the Cold War, albeit usually at lower power levels. The sheer scale of this facility suggests they were investigating these concepts at a much larger, potentially operational scale. Furthermore, the facility might have played a role in calibrating or understanding the performance of other strategic systems. For instance, analyzing how the ionosphere affects signals from satellites, or how it impacts the accuracy of guidance systems reliant on radio waves. By actively modifying the ionosphere, they could create controlled conditions to test the robustness of their own or potential enemy systems against such disturbances. The project could also have been part of a broader effort to understand and potentially exploit natural phenomena related to the ionosphere and magnetosphere, perhaps searching for ways to detect missile launches, nuclear tests, or other strategic events by observing subtle changes in the Earth's electromagnetic environment caused by the facility's transmissions or by other sources. The weather control rumor, in this context, serves as an almost perfect red herring, diverting attention from these more plausible, strategically focused activities. It's easier for the public to grasp the idea of manipulating storms than the complex physics of ionospheric propagation, OTH radar, or strategic communication links. The multiple possible purposes highlight the multifaceted nature of Cold War research. Projects often had layered objectives, starting with fundamental research and exploring various potential military applications simultaneously. It's likely this facility was not built for a single narrow purpose, but rather as a versatile platform for high-power electromagnetic experiments with a range of potential strategic payoffs, all centered around the crucial interaction between massive radio energy and the upper atmosphere. Operating a facility of this scale and technical complexity was fraught with challenges, both technical and human. On the technical side, maintaining the massive power generation systems, the intricate network of antennas, and the cutting-edge electronics was a constant battle. Components failed, especially under the stress of high-power transmissions. The vacuum tubes and early solid-state electronics of the era were less reliable than today's technology, requiring constant monitoring and replacement. The antenna arrays, exposed to the elements in a potentially harsh climate, required regular maintenance to prevent corrosion, ice damage, and structural fatigue. Calibrating and synchronizing the signals from hundreds of individual antenna elements to precisely steer the powerful beam was a complex task, sensitive to temperature changes and structural shifts. The power systems themselves presented significant challenges. Delivering and managing megawatts of electricity generated tremendous heat, requiring extensive cooling systems. High-voltage equipment posed safety risks, and the sheer energy consumption was enormous, potentially requiring dedicated power infrastructure that was expensive to build and operate. From a research perspective, the biggest challenge was likely achieving predictable and controllable effects on the ionosphere. The ionosphere is a naturally dynamic system, constantly changing in response to solar activity, geomagnetic storms, and other natural factors. Isolating the effects of the facility's transmissions from these natural variations was difficult. Experiments might yield inconsistent results, making it hard to validate theories and refine operational techniques. The desired ionospheric modifications might be short-lived, localized, or simply not achievable with the power and frequencies available. These technical hurdles led to setbacks, delays, and potentially disappointing results compared to the ambitious initial goals. On the human side, the isolation of the facility took its toll on the personnel. Living and working in a remote location, under strict security protocols, with limited contact with the outside world, created psychological pressures. Scientists and engineers, driven by the importance of their work but also facing technical frustrations, might have experienced burnout or strained relationships. Maintaining morale and discipline in such an environment was crucial for the project's success. The need for absolute secrecy meant that personnel couldn't discuss their work, even with family, creating a sense of isolation and potentially leading to misunderstandings or fueling speculation among outsiders. Furthermore, the project likely faced bureaucratic and political pressures. As years passed and costs mounted without achieving definitive, demonstrable breakthroughs, questions might have been raised in Washington about the project's efficacy and return on investment. Funding could become precarious, subject to shifts in political priorities or budget cuts. Internal conflicts might arise between different teams or agencies involved, each with their own agenda or assessment of the project's progress. Unexpected side effects of the high-power transmissions could also have caused problems. While unlikely to cause actual weather changes, intense electromagnetic fields could interfere with local electronics, communication systems, or even potentially have biological effects on wildlife or personnel, leading to health concerns and investigations. These issues, coupled with the primary technical and scientific challenges, painted a picture of an operational phase marked by both dedicated effort and persistent difficulties, far removed from the effortless control implied by the weather control myth. It was a struggle against the limits of technology, the unpredictability of nature, and the realities of managing a massive, secret government enterprise. The decision to abandon the facility was likely a complex one, resulting from a confluence of factors rather than a single dramatic event. The most probable cause was a combination of technical limitations, changing strategic priorities, and financial constraints. As mentioned earlier, the operational phase was marked by significant technical challenges and potentially inconsistent results in achieving predictable, controllable effects on the ionosphere or realizing the full strategic potential envisioned in the initial proposals. Despite years of research and massive investment, the technology might simply not have matured to the point where the facility could reliably serve its intended purpose. Whether that was optimizing OTH radar, ensuring submersible communication, or pursuing other electromagnetic warfare goals. The ambitious goals might have proved scientifically or technically infeasible with the technology available at the time. Furthermore, the strategic landscape of the Cold War was constantly evolving. New technologies emerged that might have rendered the facility's purpose less critical or obsolete. For example, the development of advanced satellite surveillance, alternative communication methods that didn't rely on ionospheric reflection, or improvements in stealth technology could have reduced the perceived value of a ground-based, high-power ionospheric interaction facility. Military priorities shifted, and resources that were once dedicated to this project might have been redirected to areas deemed more pressing or promising. The financial burden of maintaining and operating such a massive facility was also significant. High energy costs, maintenance expenses for complex equipment, and the salaries of a large workforce added up. If the project wasn't consistently delivering tangible results, or if its strategic relevance diminished, the cost-benefit analysis would eventually tilt towards shutdown. Budget cuts, political opposition to costly long-term projects, or a general shift in defense spending could have sealed its fate. The end of the Cold War itself in the late 1980s and early 1990s marked a significant shift in strategic priorities. While the project might have begun earlier, if it was still operational or in development during this transition, the rationale for maintaining a costly, offensive, defensive electromagnetic project might have evaporated. Declassification efforts or internal reviews might have exposed the project's technical shortcomings or questionable effectiveness, leading to a decision to cut losses. The abandonment process itself wouldn't have been immediate. There would have been a phased shutdown, equipment decommissioning, with sensitive technology likely removed or destroyed, personnel reassignment, and finally securing the site before leaving it to nature. The fact that large, non-sensitive structures and foundations were left behind suggests that a full, environmentally responsible demolition was deemed too costly or unnecessary given the remote location. The speed of the decay visible today speaks to the harshness of the environment and the deliberate decision not to maintain the site. The remnants stand as a monument to a specific moment in technological history, a time when immense resources were poured into pushing the boundaries of physics for strategic advantage, sometimes resulting in groundbreaking capabilities, and sometimes in costly, ambitious projects that ultimately failed to deliver and were simply left behind, allowing myths and legends, like weather control, to take root in the fertile ground of public ignorance and speculation about what really went on behind those fences. The silence of the abandoned facility today is perhaps its loudest statement, speaking of the transient nature of even the most powerful and secretive human endeavors when confronted with the relentless march of technological progress, changing political climates, and the simple passage of time. Today, the abandoned facility stands as a stark, decaying relic, a monument to a bygone era of technological ambition and Cold War secrecy. The immense antenna structures have largely collapsed or been dismantled, leaving only twisted metal skeletons and concrete foundations. Buildings are gutted, stripped of anything valuable or sensitive, leaving behind empty shells open to the elements. The environment is slowly reclaiming the site, weeds pushing through cracked pavement, rust blooming on exposed steel. Yet despite the decay, the scale of the operation remains impressive, hinting at the enormous resources and effort that were poured into this place. The local legends of weather control persist, passed down through generations, fueled by the site's imposing appearance and the lack of official, understandable information about its true purpose. This gap between the visible remnants and the hidden reality is fertile ground for speculation, allowing the most dramatic and fantastical theories to thrive. The real purpose, likely centered around sophisticated ionospheric manipulation for strategic communication or surveillance, is far less glamorous than controlling hurricanes, but arguably more significant in the context of the Cold War struggle. It represents a real, albeit perhaps unsuccessful, attempt to weaponize or leverage fundamental physical principles for military advantage. The legacy of this facility is multifaceted. It serves as a reminder of the lengths to which governments will go in the pursuit of technological superiority, funding ambitious projects under deep layers of secrecy. It highlights the inherent risks in pushing the boundaries of science and engineering. Some projects succeed spectacularly, while others, like this one seems to be, consume vast resources before being quietly abandoned, their initial promise unfulfilled. It also underscores the power of myth and rumor in the absence of transparency. The sensational weather control story, while factually incorrect, is far more enduring in the public imagination than the complex reality of ionospheric physics and strategic radar. The facility's abandonment isn't just a physical event, it's a historical marker, signifying a shift in technological paradigms and strategic thinking. Perhaps the lessons learned, or not learned, from this costly endeavor influenced later research or prevented similar projects from being pursued down blind alleys. Perhaps some of the fundamental research conducted here, even if the ultimate strategic goal was not met, contributed incrementally to our understanding of the upper atmosphere or electromagnetic propagation, knowledge that was later applied in less ambitious, more successful projects. The ruins prompt reflection on the nature of progress, the ethics of secret government research, and the disconnect between the public's perception of such activities and the complex, often mundane reality of their inner workings. The question posed by the title lingers: what was its real purpose? Based on the physical evidence, the historical context, and the plausible technologies of the era, the most likely answer points away from sci-fi weather manipulation and towards a sophisticated, high-power attempt to to master the ionosphere for strategic military advantage, a goal that proved perhaps too ambitious, too complex, or simply too late to justify the continued existence of this colossal, now abandoned machine on the American landscape. What do you think was the most likely real purpose for a massive secret facility rumored to control the weather during the Cold War?